It says I'm live. I hope it's true. Hello. We're going to bounce some chemical equations today, but hey, what better thing is there to do on a Saturday night? At least it's Saturday night where I am. Of course, anywhere in the world you might be. Hey, maybe it's Sunday morning, but that's still a good time to balance chemical equations, right? I'm Karen McFarland Holman. I am a chemistry professor, and StudySoup is here to help you, and I'm here to help StudySoup and help you. And we gotta help get you ready for a chemistry exam, or maybe you're doing chemistry homework or anything else. That's what we're here to just support you in that way. So I'm going to see if this is also streaming onto YouTube. That's the plan. That's the hope. That is the dream. And I'm currently, oh, this is so cool. Do whatever it is you need to do. So or anything else. So let me see if I can get this rolling so that I can maybe see it better. Yeah, it says it's live. Okay. Oh, that's so great. Oh, I'm so excited. This is fantastic. Okay. So let's switch the view here. And I'm still here, but I'm going to be in the corner, and I want us to focus down on the paper here so that we can write out some chemical equations and we're going to balance them. Okay, so that is the plan. Balancing chemical equations. And okay, so this is called balancing. And yes, I love my calligraphy pens. Balancing our chemistry equations. Formally, this actually isn't a calligraphy pen. It's a fountain pen, but, you know, they're still both fancy. Okay. So with balancing chemical equations, chemistry equations, we need to keep in mind that we must adhere to laws of the universe and specifically conservation of mass. So on one side of a chemical equation, we've got some compounds that are reacting together and then forming products. And the mass on the reactant side must always equal the mass on the product side. We are just rearranging the elements that are there. And so that is our plan when we have, for example, lead 2 sulfide is the name of this compound. When it reacts with hydrobromic acid. Okay. And forms lead 2 bromide and dihydrogen sulfide. So in terms of, when I'm saying lead 2 sulfide, and you're wondering, well, where's the 2 here? I'm referring to the oxidation number of the lead, and it's +2, and the sulfide is -2. And so those charges cancel out, giving us this neutral compound. Okay. So now, in terms of balancing, this means that we need to have the same number of lead on both sides. So I'm going to write down lead. We'll take notes down here. This is just going to be our tally. Lead on this side and lead on this side. We need to make sure that we have equal numbers on both sides of that element. What else do we have? We have sulfur. Bromine, which is an ion. So we can say bromide. But in any case, we're just focusing on these elements themselves, making sure there's the same number on both sides. So the place where I always begin is I just count them up to begin with. What is this unbalanced equation showing us in terms of numbers of each of these? So I just count them up. I see, okay, there's only 1 lead on this side. And looks like there's only one lead on that side. Okay, could be a balanced chemical equation, but let's see. 1 hydrogen. Ooh, there we go. 2 hydrogens, not balanced. And then here is 1 bromine on this side and 2 bromines on this side. Okay, so this is our starting point. And now what we need to do is check this side and say, okay, is there a way that we can balance the hydrogens and the bromines on both sides by putting a coefficient? We call it a stoichiometric coefficient in front of one of these compounds. This one makes the most sense. It's got both hydrogen and bromine in it. And so if we put a 2 here, then we can update our tally on this side, and we change the number of hydrogens that appear on this side to 2. And this 2 here, this multiplies through. It refers not only to the hydrogen, but also to the bromine. And so that means the number of bromines has changed as well. And now we cross-check. Do we have the same number of everything on both sides? 1 and 1 lead, yes. 1 and 1 sulfur, yes. 2 and 2 hydrogens, yes. 2 and 2 bromines, yes. And check. We have a balanced chemical equation. Fabulous. Okay. So that one, we only had to put 1 stoichiometric coefficient in, and then we were done. So that's pretty cool. Let's look at another example. Let's look at this one here. That is sodium hydroxide. By the way, I'm not including all of the phases, such as aqueous, or if it's a solid or a gas, because we are focusing on balancing chemical equations right now. We could include those if we wanted to, but I really want to just look at the problem at hand, which is making sure these are balanced. Okay. So here we've got, oh, this is so funny. I have a little spider that is really, really tiny spider walking on my microphone. And it's red. It's a tiny red spider walking on a red microphone. That's pretty cool. Okay. So we have sodium hydroxide and we have aluminum nitrate. These react together. It happens to be an aqueous phase, in case you were curious. And it forms aluminum hydroxide. This is a precipitation reaction, by the way, because this is a solid that forms. And sodium nitrate. Okay, so with this one, I am going to show you a little trick. And this is a trick that you can use when there are polyatomic ions that stay intact. Okay, so here's a polyatomic ion, nitrate. It is NO3 minus 1 charge. And notice how it's on this side as NO3, and it's in parentheses, and there's 3 of them. And then it's still over here, still intact as a polyatomic ion. So you can actually treat that as a unit. Okay, now this only works if there's a polyatomic on both sides, the same polyatomic. So I'm going to show you how that works here. So let's go down our list as we did before, where we're listing, in this case, the elements. We'll do that with sodium. That's on both sides. But now I am going to include, we're going to try this, see how this works. And then what else do we have? We have aluminum. And we have aluminum. Notice I'm not putting the charges on the sodium and the aluminum because we're just keeping a tally of what's there. We're just counting them up, okay? And then we have this nitrate that I was just mentioning. That's also a polyatomic. The hydroxide here, it's polyatomic, so is the nitrate. Now, I would like to mention, if you prefer to have your hydrogen separate from your oxygen, separate from your nitrogen, you can absolutely do that. There is no problem with it. You will still get a correct answer. I am just showing you that this is easier and faster. So, a little tip, but if you're not comfortable doing it, then don't. Always do whatever you feel the most comfortable with and the most confident with. Okay, so let's take a look. I'm going to get my red pen out here and let's count them up. Let's count up the sodium that's on both sides. 1 and 1. This time I'm going reactant side, and then aluminum is +3 charged and hydroxide's minus 1. And so we need 3 of them in order to make this a neutral compound. Okay, so we've got 3 hydroxides. We can already see this is not balanced to start. We have 1 aluminum and we have 1 aluminum. And how about these nitrates? Over on the reactant side to change, right? So let's take a look over here. We have 3 nitrates on this side. So there's something we could do to balance out the nitrates. And that is we could put a 3. But it has also changed the number of the sodium ions. Okay, so we need to keep that in mind, that we just changed that. Okay. So we're not quite done yet, are we? Okay, so we have to balance not only the sodium ions, but also the hydroxides. There's 3 on each side, and over here there's only 1. Here's sodium hydroxide. So let's put a 3 in front of sodium hydroxide on the reactant side. That changes not only the number of sodiums on this side, on the reactant side, but it also changes the hydroxide. So that worked in our favor because now we've got 3 and 3 sodiums. Excellent. Those match. 3 and 3 hydroxides. Great. 1 and 1 aluminum and 3 and 3 nitrates. So check. We have a balanced chemical equation. Yay. All right, shall we do another? We have time. Let's look at one. I want to increase the complexity of these, right? This first one we did, we just had to add 1 number. The second one we did, we just had to add 2 stoichiometric coefficients to balance it. All right, so let's do another where perhaps there's more. Okay, let's look at a compound called ammonium nitrate. Ammonium nitrate Ammonium is a polyatomic ion. It's +1 charged. And nitrate is a polyatomic ion. That's -1 charged. So these two can form an ionic compound. And it is actually explosive. It's a solid compound, but it can explode. And when it does, it releases nitrogen gas. It also releases oxygen gas. And it also releases water. Now, because explosions release so much energy, they release a lot of heat with them, you can bet that these water molecules are in the gas phase as well. They're vaporized. Okay, so this is something that's very typical of explosives, that they are in the solid form to begin, and then something happens. Usually they're ignited in some way. and then they create a lot of gas molecules that then fly outward. So very typical kind of thing that occurs. Okay, so let's take a look at this. Now notice, remember my trick I mentioned with if you have a polyatomic on both sides, you can list them as a unit. But look at here, we have a polyatomic ion on this side, and we do not have that polyatomic on this side. Here with the nitrate, polyatomic on this side, but it does not exist on this side. So we can't use that trick anymore. So instead, that's okay. We are going to list out each one of the elements on both sides, and we're going to balance this. So here's our nitrogen. Let's list that. Nitrogen. What else do we have? We have hydrogen. And we have oxygen. And that is the same with this side as well. We've got nitrogen, hydrogen, and oxygen. Okay, so we're going to add these up, see where we're at to start, and then see what we have to do to balance this chemical equation. Okay, so to begin, how many nitrogen atoms do we have? 1, 2. Hydrogens on this side, on the reactant side, we've got 4. And oxygens, we've got 3. Okay, fantastic. Now, how about this side? We've got 3 products here. So we have to make sure that we're checking all of them and see which ones have nitrogen in them. Just this one. And it has 2 nitrogens in it. It's diatomic nitrogen. Okay, how about hydrogen? Nope. 2 and H2O. So you add those up and together, 3 oxygens. Okay, we've got to do some balancing here. So here's where we begin. We look at nitrogen and we see 2 nitrogen, 2 nitrogen. So to start with, let's not bother doing anything with the nitrogens. Let's work on those that we actually need to change, okay? And so a good place to start would be with the hydrogens. We have 4 hydrogens on this side, and we have 2 on this side. So one way to help the situation is to put a 2 here, which then causes hydrogen to be 4 on this side, because this 2 distributes through and water already had 2 hydrogens, so now there's 4. And we have now increased the number of oxygens by 1 by putting this 2 here, meaning we've got 2 oxygens now from the water, the 2 waters, and we have 2 oxygens from this O2. So that means we now have 4 oxygens, right? Because now there's 4 on the product side and there's 3 on the reactant side. Okay. Whenever you've got an odd number and an even number, my tip for you is to go to the side with the odd number and double it. Okay, so that will then cause this odd number to become an even number, and any even numbers will stay even. Okay, so let's now, after having put that 2 there, let's multiply through all of these by 2. We now have 4 nitrogens, we now have 8 hydrogens, and we now have we have 6. 2 times 3 is 6 oxygens on the reactant side. Okay, now what do we do? So now we go back to this side. So this is a great example. See how we're going back and forth and fixing what we've done until we get to that balanced state. Now with the hydrogens, if we wish, we could look at this 4 and acknowledge that the 2 nitrogens come from this N2. And we can put a 2 here, causing the product side to now have 4. So the nitrogens are now balanced. That's great. Okay, what about the hydrogens? What could we do here? We've got 4 hydrogens, but we need to have 8 on the product side for this to be balanced. Okay, so what we could do, instead of having a 2 here, we could instead have a 4. That then causes the number of hydrogens on the product side to be 8. And the number of oxygens on the product side now, we've got 4 that are coming from this water, because we have 4 waters, 1 oxygen each. And we have an O2 here, right? So we add all those up and we get 6 oxygens on the product side. It's looking pretty good, but we always double check at the end. Okay, so let's do that double check. We've got 4 nitrogens, 4 nitrogens. Yes. 8 hydrogens, 8 hydrogens. Yes. 6 oxygens and 6 oxygens. Yes, indeed. Check. We have a balanced chemical equation. Fabulous. Well, I hope this was helpful for you, and let me know in the chat if you have other requests, if you have questions about any of these that we went over, or if there's any chemistry problems that you'd like to see in the future. I'll be live streaming, and I love to help students learn chemistry. That's what I'm here for. That's what StudySoup is here for. So be sure to check out StudySoup.com if you want to find out more about the resources that are available to you. I am Professor Karen McFarland Holman, and I'm a chemistry professor, and I'll be live streaming chemistry here on this channel for you. So take care, and I will see you again next time.